Well, let's get started here. So unless there are questions, I'll just start working through a practice final I have from, well, it's from last year. Remember last year we had this weird thing where we didn't come back after Thanksgiving because of COVID, remember? If you were here, you remember. So like last year, I gave a shortened final exam before Thanksgiving, and then I gave like a take-home part of the final after Thanksgiving. So that's why this final isn't quite an adequate representation of what a final should look like in here, because it's missing some material. The part that's missing on the final exam I posted is the quadratic material, like how to solve quadratic equations. Remember we completed the square and all that. So I'll try to do some examples of that today in addition to this. But I'll start by just working through this final. I think it'll be helpful for you guys. So here's problem 1. We're asked to solve minus 4x plus 22 equal to 3x minus 20. All right. And then problem 2 is to solve minus 3/10 x plus 1 equal to 7/5. And then problem 3 is to solve the absolute value of 4 minus 5x equal to 6. All right. So let's work on them. Let's see here. So what should we do for the first problem? What, maybe add 4x to both sides and subtract 22 from both sides? Does that make sense? Or add 20 to both sides, right? So we have minus 4x plus 22 equal to 3x minus 20. If I add 4x to both sides and I add 20 to both sides, what happens? We get what? The 4x's cancel. We get 42 is equal to, what is this? 3 plus 4, 7x. The 20's cancel. So this gives us what? X equal to 42 over 7, which is 6. So that's the first problem. I think everybody will get this problem right. If I put a problem like this on the final, I don't think anybody's going to, pretty much everybody should get that one right. How about this one? What would you guys suggest I do for this next problem? Okay, subtract 1 from both sides. Okay. So we go minus 3/10 x equals to 7/5 minus 1. I like that. We can make a common denominator here, right? So this would be like 7/5 minus 5/5, right? So you really got 2/5, right? I'll rewrite it again. We have minus 3x over 10 is equal to 2 over 5. So we could we could cross multiply if you like. You know, we could, or we could just multiply both sides by 10. How about that? Minus 3x is equal to 2/5 times 10, right? And what is 10? 10 over 5 is 2, right? So that gives me 20 over 5. I mean, 20 over 5 is 4 on the right-hand side. So we get 4 here, right? So x equals to what? X equals to 4 over minus 3. So that's a fine way to solve this. Can you guys think of a lazier way where we would have avoided, we had to work a lot with fractions that time, right? How could I have made this problem easier by getting rid of fractions at the start? How about if I just, Yeah, like this, the original problem, if I had multiplied this by 10, see, then that would have been good because 10 will clear out 10 and fifths. Like the least common multiple of 5 and 10 is 10, because 5 times 2 is 10. So if I'd multiplied that problem by 10, what would that have given me? Well, that would have given me minus 3x plus 10 equals to 14, which would have given me minus 3x is equal to 4, which would have given me x is equal to minus 4/3. So if you look at the calculation in purple, you can see it's a little bit easier if we work on clearing out the fractions at the start by multiplying by the least common multiple, right? But be careful. If you do multiply the equation by 10, you need to make sure you distribute the 10 both to the first term and the second term, right? Distribution. The distributive property is important, otherwise it'll go bad for you. How about problem 3? How should we solve this problem? What we need to solve, there's 2 problems to solve, right? Mm-hmm. Equals to 6, right? Or what's the other? See if this is, if that's equal to minus 6, either one of these choices gives you absolute value of 4 minus 5x equal to 6. So there are going to be 2 solutions here. And, okay, so we get 4 minus 6 equals to 5x, which is minus 2 equals to 5x, which gives us x is equal to minus 2 over 5. That's one of my solutions. And over here, we get 4 plus 6 equals to 5x, which is 10 equal to 5x, which gives us x equals to 10 over 5, which is, of course, also known as 2. So 2 solutions for that one. Oh, goodness. This one's hard for me to, well, I'll work on it. It's easier for you to look at than it is for me to write, that's for sure. So I give a graph, all right, and it's got a grid on it, all right. It starts, there's a dot at minus 8, minus 4, and then it goes, crosses the y-axis at here, and then it goes up to 4, 4. Here is an open circle. The lines aren't dotted. I'll fix it in a second here. And then it starts again at 6, 6, close dot, and goes up to 8, 8. This point here is 6, 6. This point there is 4, 4. All right, and we're told that this is y equals f of x. I'll make the graph red so you can see it better. Oops. All right, so there's y equals f of x. Then the question is simply this: what's the domain and what's the range using interval notation? I probably should move the camera since it's off screen at the moment. So what do you guys think? I'll write it in words, right? This is all x values in y equals f of x, right? And this is all the y values in y equals f of x, right? I mean, it's all the x values which are actually attained. It's all the y values which were actually attained. Like, they're actually reached, right, by some point in the graph. So how about x? We go from what? From minus 8 included all the way over to 4. Is 4 included or excluded? Yeah, no, it's not included. So we got to do the curl of the parentheses there. Then we do union with, starts again at 6, and it goes all the way over to 8. Both of those are included because of the solid dots. So that's the domain, right? How about the range? So where do we start? What's the lowest y value? -4 included, right? And then all the way up to 4. Is it included or excluded? Excluded, right? Then we take the union with, again, as it happens, 6 to 8. And there you go. All right. The next problem on the test is a word problem. Here we go. The perimeter of a playing field is 900 feet. Yeah, I got to do that. Thank you. The perimeter of a playing field is 900 feet. And the field is a rectangle, and its length is twice the width. So the perimeter, 900 feet. And we need to draw a picture. So let's say this is the length, this is the width. We're told it's a rectangle, right? And we're also told that the length is twice the width. The length is twice the width. So we can say L is equal to 2 times W, right? Then the question is find the length and the width of the field. All right? So you guys tell me, what should I do here? I need to write down an equation, right? Yeah, well, I didn't ask anything. We could have asked about area, but I didn't. If we did want to find area, we would do length times width, right? What's the perimeter, though? 900, right? So it's what we got, 900 equals to what? Well, this is length, this is L, this is W as well, right? So we've got W plus L plus L. I mean, that's the sum of the lengths of the fence, right? The fenced area, that's the perimeter. Of course, that's 2W plus 2L, right? But we can get rid of L with W, right? That's 2W plus 2 times 2W, isn't it? Because we know that the length is twice the width. And so what do we have? We have 2 times 2 is 4, 4 plus 2 is 6. We got 6W. So W is equal to 900 over 6, right? Which I think is 150. So this tells us that the length is equal to 300 feet and that the width is equal to 150 feet. And if you do a quick check on that, you see that that works, right? Because you get 300 plus 300 plus 150 plus 150, that's 900, right? So that answer makes sense. You can check it. What would the area be? So you could just multiply, it would be 150 times 300 if you wanted to find the area, right? So. An evaluation question next. This becomes an increasingly important topic in like the next, if you go on to pre-calculus, this particular calculation I'm about to show you becomes more important. Problem 6. Okay, so I tell you here that P of x is given by the formula 8x to the 6th plus 7x to the 5th plus 3x plus 9. And then it says calculate P of minus 1 and P of 0. All right, so what do we got? So what that means is we have to plug in minus 1 for x, right? So we've got 8 times minus 1 to the 6th power plus 7 times minus 1 to the 5th power plus 3 times minus 1 plus 9. And then P of 0, 8 times 0 to the 6th power plus 7 times 0 to the 5th power plus 3 times 0 plus 9. Now, of course, you can use your calculator to punch these things in, right? But if you stop and think about it for a second, you don't really need your calculator, right? The key facts here are that minus 1 to an even power is 1, right? Like minus 1 squared is 1, minus 1 to the 4th power is 1. But minus 1 to an odd power, like minus 1 to the 3rd or minus 1 to the 5th, those are minus 1. So this is just 8 minus 7 minus 3 plus 9, right? Which you probably can do that without a calculator, right? That's 8 plus 9 is 17. Then you subtract 10 in the middle. So 17 minus 10 is what? 7, is that right? Or did I do? Let me just do it. So 8 minus 7 is 1. 1 minus 3 is minus 2. Minus 2 plus 9 is 7. So however you want to do that, 7. How about the next one? I didn't really need to write everything down, did I? Because if you think about it for a second, when you plug 0 into this, the only thing that matters is that guy, 9. So. I hope everybody gets that kind of problem right if we put it on the final, right? Because this is, I mean, honestly, this is a gift, right? All you have to do is take the number, plug it in, and follow the rule. It's not bad, is it? Okay, problem 7 is something you guys had trouble with on test 1. So problem 7, we must go through problem 7 here. Here we have solve each inequality and below and give answer in interval notation. All right, so A, here we have minus 3x plus 4 less than x plus 12. Start with that one. So what do you guys want to do? Subtract 4 from both sides. I like that. So that will give us minus 3x is less than x plus 12 minus 4, right? Which is x plus 8, right? So we've got minus 3x is less than x plus 8. I'll just write it again there. Then what? Oh, I forgot to... Oh, yeah, so I want to bring all the x's to one side, right? What should I do? Subtract x from both sides or add 3x to both sides? Which way do you want to go? Subtract x? All right, so that gives us minus 4x is less than 8, then what? Divide by -4. All right? So when we do that, what happens? We have to switch the inequality from less than to greater than, right? Because when we divide by a negative number, it flips the inequality over. That's the rule. So what that gives us is x is greater than -2. And maybe it's helpful to draw a number line. So here's -2. Where is x? X is greater than -2, right? So x is like over here. And so if on a number line, the solution looks like this, right? So I should write what? My answer is -2, not included, to infinity. That's the solution set to this inequality in interval notation. All right? What's up next? Next we have absolute value of 3x plus 2 less than 1. So how do we solve such an inequality? The same method. Well, yeah, but notice the absolute value, right? So what we learned is that this is equivalent to -1 less than 3x plus 2 less than 1. So when we have less than, absolute value is less than something, we can just unwrap the inequality like that. Okay, so like to give you another example, if we had 3x plus 17 was less than 4, that would give us -4 less than 3x plus 17 less than 4. If there's an equality here, it goes here and here. Side note, you know. Okay, so, but once we have this, then it's just like before. So subtract 2 across the inequality, we have -3 is less than 3x is less than -1, right? So I just subtract 2 across each one, yeah? And then I can divide by 3. Now 3 is positive, so when you divide by a positive quantity, it doesn't reverse the inequalities. So dividing by 3 gives me -3 over 3 less than 3x over 3 less than -1 over 3, which of course tells me that -1 is less than x is less than, well, -1/3. On a number line, if this is -1 and this is -1/3, x is up in here somewhere, right? So the answer is -1 to -1/3. C is absolute value of 3x plus 2 greater than or equal to 1. Now that's a very different problem. See, because the absolute value of 3x plus 2 greater than or equal to 1, there's two possibilities. Either you have 3x plus 2 greater than or equal to 1, or you have 3x plus 2 less than or equal to -1. You can't write it as a compound inequality like we did in part A. There's an asymmetry between the less than or greater than. You got to be aware of this. They're really quite different. But now we can solve these separately, all right? So the first one gives me 3x greater than or equal to -1. The second one gives me 3x less than or equal to -3. Divide by 3, I get x greater than or equal to -1/3, or x less than or equal to -1, dividing by 3 in both cases. So here, if you draw the number line, you got -1/3, right? And x is greater than that, right? So like x is in here somewhere. On the other one, you've got -1, and you've got x here, right? x is somewhere in here. Now, if you drew them both on the same number line, that might be helpful. So minus 1 comes before minus 1/3, by the way. And so we've got two separate intervals. There's either x over here or there's x over there. And my pictures are flip-flopped, yeah? Like this is that one. This is that one. So the answer in this case is minus infinity all the way up to minus 1 included, unioned with minus 1/3 to infinity. If you put parts B and C on the same number line, you'd see that like you put them both together, you get all real numbers. So essentially, the answer to part C is everything that's not the answer in B. Like you fill in the dot and go this way, or you fill in the dot and go that way. That's what we have down here. I put a problem like this on their test, and I put a problem like that on their final. I put a problem like this on your test. I wonder what might happen on your final. Let's see here. So, problem number 8. Ooh, graph a line. So, when I asked you guys to graph a line, I think on test 1 or 2, I can't remember which one it was. It didn't. Some of you got it, but a lot of you didn't, and I think that's something you need to fix. So I would say plot the points, 8 minus 2 and 2, 6, I think. So I give a grid on the actual test, all right? And so, there's a grid. So minus, let's see here, I'll just put some representative tick marks here. All right, so I say plot the points minus 8 comma 2. So that's x is minus 8, 2. That's like here, right? And 2 comma 6. So that's like here. Again, you don't have to be ambiguous on your test. There's actually a grid. All right. So I say plot those points. And then I say find the equation of the line which passes through the given points and graph the line. So graphing the line that's the easy part, isn't it? Because, well, you guys remember connect the dots. If you're like me, you enjoyed playing connect the dots when you were a kid. Let's see here. It's like my favorite thing. So that was my attempt at drawing. That's the graph of the line. Now, how should we find the equation of the line? What would you guys suggest I do? Well, there are various different approaches. If you knew the 2-point formula for a line, you could just plug the points into the formula and you'd have it immediately. Would you like that? You guys are allowed to bring a page of notes to the final, right? So you could put the 2-point formula for the line, the slope-intercept formula for the line, the 1-point formula for the line. I'll show you them all. And you guys choose line formulas. You could write y is equal to mx plus b. You choose the slope intercept, right? It's the y-intercept, right? There's also the 1-point formula for the line, y equals to, say, y1 plus m times x minus x1. So this, this time you have slope m point x1, x1, y1 on line. That's another formula for the line that we know. The 2-point formula for a line looks like this. Y is equal to, let's say, y1 plus parentheses y2 minus y1 over x2 minus x1 times x minus x1. So this is the 2-point formula. So if we want to be lazy, the most lazy thing to do here is to use the 2-point formula, right? Because we have 2 points. We're trying to find the formula, so 2-point formula. That's the way to go, right? If I gave you slope-intercept, then obviously we want to use slope-intercept, you know? Really, you can use any one of these formulas and then do algebra to figure out the rest. Like, it's not the end of the world if you don't know one or the other. You just need to use one of them and think. But in the interest of not thinking too much here, I'll just say, let's say minus 8, comma 2 is x1, y1. And let's say that 2, comma 6 is x2, y2, right? And with that in mind, we've got y equal to, y1 is 2, y2 is 6 minus 2 divided by x2, which was 2. x1 was minus 8, so I do minus a minus 8. And then x minus minus 8. Let's clean that up a bit. So that's 4 over 10, right? 4 over 10 is 2/5, so I do 2 plus 2/5 times x plus 8. So you could do it like that if you like. For example. What would the slope-intercept form of this line be? If you wanted to find slope-intercept, what do? You just multiply it out, right? So we got 2/5 x plus 16/5. Yeah, the slope is 2/5, right? So this is 2/5 x. 16/5 plus 2 is 26/5. So there you go. There's the slope-intercept form of the equation of the line right there. But if I don't say otherwise, if I just say find the equation of the line, I take this as an answer, I take that as an answer, I'll take any form of the equation of the line as an answer unless I specify otherwise. So I'm just happy for you to find an equation of the line which is correct. I don't, whether or not you understand the difference between the terminology slope-intercept or point slope is less important to me. I do want you to be able to graph the line. A lot of you were not able to do that on the test where I asked about it. But I believe every person taking this course can graph a line. I refuse to believe people can't graph lines. Okay, so problem 9. Problem 9. Here we've got, you're supposed to solve 3x. It's been a while since we've done these, right? But here it is. 3x minus 2y equals to 8. And 5x plus y equals to 9, right? So how did we solve problems like this? We had 2 methods, right? Basically, we had the substitution method, and we had the, let's say, adding equations method. Which way do you guys want to go here? Substitution, yeah, I think substitution is not a bad idea, because the adding equations doesn't look very nice here. So if I do substitution, I'll pick the second one. This gives me y is equal to 9 minus 5x, right? And I basically take that, and I do what? I plug it up in there. So I get 3x minus twice 9 minus 5x equals to 8. So hooray, we have an equation with just one unknown, which we can solve, like problem 1 on this test, right? We got 3x minus 18 plus 10x equals to 8, which gives me 13x equals to 8 plus 18, which is 26, right? So x is equal to 26 over 13, which is 2, right? X equals to 2. Now what's y equal to? We go back to the formula for y, right? And that gives us y is 9 minus 5 times 2, which is minus 1. So the solution is 2 comma minus 1 if we want to write it that way. So I either take the solution as a pair or, you know, as y equals something, x equals something. I give you credit for either way of writing it, you know. Do you guys remember what this means geometrically, like what's going on geometrically here? Let me refresh your memory. So if we take equation 1 and equation 2, and we solve 1 for y, what do we get? We get 3, we get y is equal to 3x minus 8 over 2, which is 3 halves x minus 4. And equation 2, if I solve that for y, that's easier. 9 minus 5x, all right. So graphically, what's going on here, you've got a y-intercept of minus 4, and you've got a, poor choice of scale on my part. You got a y-intercept of minus 4, and you got a y-intercept of 9, right? And the slope of the one with the slope of the first one is 1.5. So I'm just going to say it's roughly like that, you know. That's the one. And I'll do the other one in red. See, that has a slope of minus 5. It's intercepted, so it's even steeper. You know, very crudely speaking, my graphs. Here's equation for 2. And the place where those lines intersect right here is actually 2 comma minus 1. As you can see, I failed to make my graph correctly, right? Because the minus 1 says that that point of intersection is below the x-axis, right? So that just means my graph is too sloppy. But the algebra is right? So when we have a single solution to a system of equations, that corresponds to the corresponding lines being skew, right? They've got some point, they're not parallel, and they've got some one single point of interception, right? What are the two other possibilities? The other two possibilities are when two lines are parallel but have different y-intercepts, there's no solution, right? And then the other possibility is both equations are actually equations for the same line, in which case you have all real numbers are solutions. So there's that. Ooh, and now the factoring. All right, problem 10. I think I forgot to go back to the line. My bad. Well, sorry about that, folks at home. All right, factoring. So here the instructions are factor each polynomial completely below over the real numbers. So we have x to the 5th minus 4x to the 4th plus 3x cubed. We have 2x squared plus 5x minus 12. We have 2x squared minus 18. We have x cubed plus 8. And finally, we have x to the 4th minus 81. So you guys tell me, what should I do with the first one? So first thing I look for anytime I'm doing a factoring problem, right, is if I can factor an x out, or something like, or x squared or whatever, I'll do that first. That's the easiest thing, right? So like, look at this. X cubed is the lowest power here. That means I can factor x cubed out of this. See, I've got x cubed times x squared minus 4x plus 3. Right? Now, notice the word completely here, right? So you got to be careful. Just because you've factored something out doesn't mean you're done, right? We're halfway there. It's a quadratic. Some quadratics can be factored, some can't, right? Can this one be factored? So if I put an x here, and I think about 3, how can I get 3? Well, 3 it's minus 1 times minus 3, right? So that can be factored as minus 1 minus 3. See, we get the minus 1x, minus 3x. We get a total of minus 4x, which is what we have up here. Minus 1 times minus 3 is 3. So there you go. And that's it. Can't go further than that. That's factored. Once you've got it, a product of linear factors repeated and linear factors, nothing more you can do to that. That's the end of the story. How about the next one? So here, I'll start us out. We'll put the 2x first, right? Put the x over here, and you guys tell me if you can figure it out. I mean, 12 is different ways to look at 12, right? We can do 12 times 1. We can do 3 times 4. We can do 2 times 6. I think those are pretty much our patterns, right? But you got to put a minus on one of them and a plus on the other, right? Because you get a minus 12. So it's got to go plus minus. And you can either put it with the first factor or the second factor. There's a lot of different possibilities here. You just got to start trying some and see if it works or not, right? Let me just write out one. If we put I'm just going to put a 12 here and a 1 here. I don't think it's going to work, but if I put, plus 12 and minus 1, see, that doesn't work, right? Because I get 12x minus 2x, which is 10x, which is not what we have, right? So that's not the answer. So I try something else. What if I put a 3 here and a 4 there? Does that work? Well, I've got a minus 8 plus 3. I got a minus 5x. Well, that almost worked. It's just I've got the wrong sign. So maybe if I just go minus here and plus there, maybe it'll work, right? Does that work? Let's see here. I get 2 times 4 is 8x, minus 3x is 5x. Hey, there it is. So you have to think about the ways we can factor 12 and just check possibilities until you get it. You got to check your answer, though, right? How do you check your answer? You think about multiplying this out, right? The way we check answers for factoring is to multiply. But there it is. The next one is I think a little bit easier, right? I would say to start with, factor that 2 out, right? we've got 2 times x squared minus 9, right? Let me suggest that we write 9 instead as 3 squared, right? See, now we have the difference of squares. Remember the difference of squares pattern? What was it? So if we have a squared minus b squared, we have a plus b times a minus b, right? So we can always fall back on this difference of squares formula. And so applying that here, I've got 2 times x plus 3 times x minus 3. So always look for difference of squares when you're factoring. If you can see it, great, you know. That's a nice thing to be able to use. Notice we can do difference of squares in part E too, right? See that for part E? Down here, we have x squared squared minus 9 squared, so that's actually x squared plus 9 times x squared minus 9. But we already know that x squared minus 9 factors just like in part C. So the answer to part E here is x squared plus 9 times x plus 3 times x minus 3. Now part D is harder in some sense, but you have to remember we covered something in here. We covered special form trinomials. You may or may not remember this, but we had a formula. And I would encourage you to put this formula on your formula sheet and perhaps this example to go with it, you know. A cubed plus b cubed, that is equal to I want to say a minus b times a squared plus ab plus b squared, if I recall correctly. Now, I got to check on that. I got to think about multiplying it out. A times a squared is a cubed. Oh, no, it's got to be, my bad. Maybe it's the plus b here. Yeah, plus b here. Maybe it's this. But there's got to be a minus somewhere in here. Maybe it's minus ab. Let me try that. So I get a cubed, I get my b cubed, I get plus ba squared, I get minus ba squared, I get, let me think about that. There's 6 total terms. Yep. So there you go. This is the special, one of the special form trinomial formulas. And so if we use that here, think of this as x cubed. What's 8? 8 is 2 cubed, right? So that's x cubed plus 2 cubed. So I think of this as being, you know, a as being x and b as being 2 in this formula here. And I've got x plus 2 times x squared minus 2x plus 4. And I'll tell you guys a secret. Anytime you have a cubic like this that you use this formula on, the resulting quadratic that goes over here, it cannot be reduced. Like this cannot be factored over the reals. So that's the answer, actually. You're like, I don't believe you that quadratic can't be factored. Okay, so maybe you're like that, right? To see why that is, if you look at x squared minus 2x plus 4, that's x minus 1 quantity squared plus 3 by completing the square. And so when you complete the square, if you get plus after you simplify the numbers, that means it can't be reduced over the real numbers. You could also calculate the discriminant of this and see that the discriminant is negative. So if you look at that b squared minus 4ac thing, you can see that you can't factor that. I'll come back to that at the end of class here. Let's wrap up this test here so we can talk more just about quadratics. All right, so we're supposed to simplify each expression. So A, I have 25 x to the 17th over 5 x to the 2. B, I have x squared over 6x plus 18 multiplied by 4x plus 12 over x. C, I have 21x squared plus 9x to the power 5 minus 30x to the 8th divided by 3x. And then D, I have 8b squared divided by 16b to the power 5 minus 24b cubed plus 8b squared. All right, so here it is. This one, 25 over 5 is 5, right? And then we have x to the 17 minus 2. So we have 5x to the 15. And that's that. The next one, I need to do a little bit of factoring. So first of all, the way this multiplies is x squared times, fine, I'll put it in between step here, 4x plus 12. I'm not really doing much here. Can I factor the 6 out downstairs? That's 6 times x plus 3, right? And I really should have went ahead and factored the 4 upstairs too. Oh well. So x squared over x is what? Just x again, right? So I have x times 4 times x plus 3 divided by 6 times x plus 3. So you see these x plus 3's cancel. And we're left with, what's 4 over 6? 4 over 6 is 2/3, right? So we have 2x over 3. So the way to do these kind of problems is you need to like factor the fractions that are involved as much as you can and look for common factors to cancel. That's how we do these. This one, since the sum is in the numerator, I am allowed to make this step. 21x squared over 3x plus 9x to the 5th over 3x minus 30x to the 8th over 3x, right? 21 over 3 is 7. X squared over x is just x, so I have 7x for my first term. X to the 5th over x is x to the 4th. 9 over 3 is 3. So I have plus 3x to the 4th. X to the 8th over x is x to the 7th. Minus 30 over 3 is minus 10. So minus 10x to the 7th. There you go. So there's that one. Now, in contrast, part D, right? Part D, I cannot do that, right? So how can we simplify part D there? Any ideas? Or is it just hopeless? There's nothing to simplify. I think we can factor a think we can factor a b squared out of the denominator, right? And maybe even an 8. I think we can factor 8b squared out of the denominator, actually, right? Because that gives me 2b to the third rather, minus 3b plus 1. Do you guys see that? So if I factor 8b squared out, 8b squared pulls out. And when I multiply this back out, right, I get minus 24b cubed. When I multiply this back out, I get 16b to the 5th, right? So we can factor 8b squared out. Certainly everyone should see we can factor b squared out, right? Whether or not you see the 8, whatever, but certainly everyone can see you factor b squared out of this. So anyway, these cancel. Woohoo! And the answer, 1 over 2b cubed minus 3b plus 1. There you go. Now, it may or may not be possible to factor that. I don't really much care. All right. In this kind of problem, you don't have to factor the end result like that if you don't want to. Yeah. But although beware, not factoring can put you in danger of not seeing something like this. So when I say not factor, I really more intend it for a problem like this where there's no, like factoring is not going to help you reduce anything, you know. Up here, factoring helped us reduce, so we wanted to do it. So finally, excuse me. Problem 12. Here we have x minus 2 over x plus 3 equal to a half. And the other problem is we have x equal to 3 plus the square root of x plus 3. We're supposed to solve these. So the first one, I usually just cross-multiply those things, you know. So basically multiply this equation by x plus 3 and multiply by 2. I get 2 times x minus 2 equals 1 times x plus 3, right? Which tells me 2x minus 4 is x plus 3. Subtract x from both sides, I get x equals to 7. So there's that one. So that's not too bad. Now this one we need to first do what? First you must isolate the radical, right? So we have x minus 3, square root of x plus 3. Then we can square both sides. And that gives us x squared minus 6x plus 9, right? So don't forget when we square, right? Another important formula, perhaps, is this: a plus b squared is a plus b times a plus b, right? Which has actually a squared plus ab plus ba plus b squared, but more to the point, that's a squared plus 2ab plus b squared, right? So don't neglect the middle term, right? That's a common error people are making on the last test, is like they're squaring a sum of two things and they're neglecting what's called the cross term, right? The 2ab type term. But anyway, here it is. And so this gives us x squared minus 7x plus 6 equals to 0, which, can you guys factor? Can you guys factor that one?